Hi, it's Alan from Crashtest Security. In this video, I will tell you how to harden TLS session resumption. So let's get started. The TLS session resumption functionality is misconfigured. This opens the possibility of stealing existing TLS sessions from other users. Generally, the TLS session resumption functionality speeds up client reconnections, as no full TLS handshake needs to occur. Instead, a value known from a previous session is used to verify the authenticity of the connection. However, if the server does not correctly rotate or renew its secrets, the session resumption breaks perfect forward secrecy. To disable TLS session resumption, follow one of our guides. Further possibilities exist to harden the session resumption feature, but are based on scheduled restarts of the web server. Relate to further reading for more information. Apache. On Apache, you need to insert the slop and scrunfum directive into the virtual host configuration in etc. Apache 2 sites enabled domainconf or etc. httpd sites enabled domainconf. For NIGs, update the configuration file, which is usually located at etc. NIGs jinsconf etc. NIGs cited enabled your site.com Ubuntu Debian or etc. NIGs confd jinsconf rhel CentOS. Add the SSL session tickets directive to the server section. To meet these security goals, we first start an in-memory key generator daemon that generates a new timestamped key every hour. Keys are encrypted so that only our NIGs servers can decrypt them. Then with Cloudflare's existing secure data propagation infrastructure, ticket keys replicate from one master instance to any or all of our POPs worldwide. Each host periodically queries the local copy of the database through a memcache interface for fresh encryption keys for this hour. To summarize, the key generation daemon generates keys randomly. It rotates them hourly, and keys are securely distributed to any or all hosts worldwide without being written to disk. There are some technical details still worth mentioning. First, we want to tackle distributed clock synchronization. As an example, there may well be one host who thinks it is UTC 12:01 p.m. while other hosts still think it is UTC 11:59 a.m. The faster clock host might start encrypting session tickets with a key of 12 p.m., while other hosts couldn't decrypt those tickets because they don't know the new key yet. Or the fast clock host might find the keys not yet available due to propagation delay. Instead of dedicating efforts to synchronization, we solve the problem by breaking the synchronization requirement. The key daemon generates keys 1 hour ahead, and each host would opportunistically save the key for the next hour, if there's any, as a decryption-only key. So now, even with one or more faster clock hosts, session resumption by ticket still works without interruption, because they will still decrypt session tickets encrypted by the other. Also, we set the session ticket lifetime hint to 18 hours, the same value for the SSL session timeout. Each server has kept ticket keys for ticket decryption for the past 18 hours. Try Crashtest Security today to discover how it integrates into your development stack for efficient, automated vulnerability scanning. The trial is free. Also, subscribe to the Crashtest Security Channel to get more information about the most significant web security threats, their prevention, and how to use the Crashtest Security Suite. Thank you for watching, and see you in our next video.